Okay, here I'm going to finish solving the no calculator portion of this mock AP Calc AB exam that I found by Lucid Education. Okay, let's finish this. So we left off on 15. Shown in the diagram is a graph of f prime, derivative of f. If f3 is 3, then f of 1 is equal to what? Okay, so what did I even do here? I don't even remember. So let me not look at that and let me see how I would approach this. So we are given f prime, okay? We can even quickly find the equation of f prime because it's just a linear line. We can use slope-intercept form. So what's the slope? It would be the change in y over change in x. The change in y is 2. The change in x is 3. So it will be 2 over 3 is the slope. Okay? And the y-intercept is -2. All right? So I could use the slope-intercept form as I said. So mx plus b, the slope we said was 2/3. The y-intercept b is -2. Okay, so this is f prime. All right, and we can find f by finding the antiderivative or integrating. So f of x is, we just do the parable, 1/3 x squared minus 2x plus c. Okay, we're given the initial condition f of 3 is 3, so we can find out what the c is. So f of 3 is 3, which is equal to 1/3 times 3 squared, which is 9. I'm plugging in x is 3. 3 squared, which is 9, minus 2 times 3 plus c. So c is equal to 6 if we simplify. So our f of x is, particular solution is 1/3 x squared minus 2x plus the c we found, which is 6. Now we want f of 1. So f of 1 is 1/3 minus 2 plus 6, which is 1/3 plus 4, which is 1/3 plus 4. Looks like b. Whoops. B. Okay? Y is the sky, dy dx is what? So we need to use quotient rule here. So bottom d top minus top d bottom over bottom squared, right? So that's what I did over here. Now it's just a matter of simplification. I distribute this 3 to both terms, distribute this 4 to both terms. And I see I have 12x and this negative 12x can cancel. We have 9 minus 16 left, which is -7. And the bottom stays the same. That is C. The quotient rule. Bottom d top minus top d bottom over bottom squared. That's how I remember it. Oh, this is easy points here. I always say fundamental theorem calculus part 1, if your book calls it part 1, is the easiest points to get. We want the derivative of this guy. When we see this, how do we take the derivative of this? Well, we plug in the limit as the variable of integration. Okay, so it'll be cosine of x cubed squared. So I plugged in x cubed as t. That's what I did there. But since it's not just x, we need to differentiate the limit with respect to x, so derivative of x cubed. Okay, so it's cosine of x to the 6 times 3x squared. Choice D. Next, integral from 0 to pi over 6, sine of x dx. Integral of sine is negative cosine. So we evaluate from 0 to pi over 6. So it's negative root 3 over 2 minus 1, or 1 minus root 3 over 2. Or, that's A, right? That one's easy. 2 easy problems on this page. Okay, moving on. Let f be the function defined by this guy. Equation of the line tangent to the graph of f at x is 2 is what? So to find the equation of the tangent line, we need a slope and a point. So the slope is the derivative. So let's find the derivative. F prime is 2x squared minus 3. We want the slope of the tangent line at x is 2. So f prime of 2 is 3 times 2 squared, which is 4, minus 3, so that's 9. Okay, we have a slope, but we need a point. We have x is 2, so y would be, we plug into here. F of 2 is 8 minus 6 plus 5, which is 7. We have a slope, we have a point slope form. Y minus 7 is 9x minus 2. And then we just put it in slope-intercept form. So y is 9x minus 18 plus 7, or 9x minus 11. Choice C. All right, this limit as x approaches infinity of this rational function. So remember, when we approach infinity, it's like it's asking what's the horizontal asymptote. Okay, so for a rational function, the very quick way is, well, we do the degree test. Degree at the top and the bottom are the same, the highest degree. So we remember how we find the horizontal asymptote of that. We just take the ratio of the leading coefficients. So that's 2 over 4, which is half. Choice C, that's the quick way to do it. If you don't remember, this is the long way to do it. You factor out the biggest degrees. So I factor out x squared on top and also x squared on the bottom. All right, so these would cancel, right? And then limit as x approaches infinity of all these would be 0, but this 2 is still there. And all these would be 0, but the 4 is still there, so it'll be limit as x approaches infinity at 2/4. This is a constant, so it'll be still 2/4, which is half. It's the same answer, right? Choice C. Obviously, this is a much quicker way. And this is a multiple choice, so you don't need to show work. Particle's position at any time is given by this equation. At what time is the particle at rest? Particle is at rest when the velocity is 0. Okay, so we need to find when the velocity is 0. Velocity is the derivative of position. So let's differentiate this. 3t squared minus 24t plus 36. I can factor a 3 from everything here. That's what I did. And then this I can factor as t minus 6, t minus 2. So our solutions, if we set it equal to 0, t is 2 and t is 6. That's when the particle is at rest, or when the velocity is 0. Shown is a graph of f prime, the derivative of f, which the following statements is true. Let's go one by one. Is f not differentiable at x is negative 2? Well, the derivative from the left and from the right are not the same, right? So it's probably A. But let's check the rest. Actually, it is true. So sorry. This is f prime. Okay, that's a key point. This guy is f prime. So is f differentiable at x is negative 2? Well, f prime exists at negative 2, so it's differentiable. So cannot be true. Okay, so I almost mixed that up. All right. F has a local min at x is negative 1. Would it be a local min? So this is f prime. F prime went from positive to negative. So actually it'll be a local max. So not true. All right. F is increasing from 1 to 3. If f is increasing, that means the derivative is positive, but the derivative is clearly negative over here. So actually f is decreasing. F is increasing from negative 3 to negative 1. Derivative is positive here, so we're good. That's probably it. F is decreasing from negative 2 to 1. Negative 2 to 1, well, the derivative is positive, so it's actually increasing. Answer is D. Okay. So we gotta be careful. I almost got fooled that. This is f prime, not f. Slope of the tangent line to this guy at the point 2, 3. So we just want to implicitly differentiate. So derivative of this guy, we need product rule. First d second plus second d first. Okay, so I actually erased that squared there. So let me even write it 4xy. Okay, and then derivative of 3 is 0. Derivative of y squared is just 2y divided by dx. Derivative of 3x squared is just 6x. Okay, so I moved all the terms with dy dx on one side and all the other terms without it on this side. So that's what I did over here. Okay, and then here I factor out dy dx from both terms. That's what I got here. And then I solve for dy dx. I divide by this guy. We want to evaluate it at 2, 3. That's what they ask us. So x is 2, y is 3. Follow the math here yourself. You can pause the video if you want. Final answer is negative 6. All right, we have this integral x cubed cosine x to the 4th dx. I can clearly see a substitution that can be made, so let u be x to the 4th. Because du is 4x cubed dx. We have a signature of the derivative there. Okay, so our integral, I called it I, is, well, it's cosine of u, because u is x to the 4th, x to the 3rd dx, that's du over 4. So du over 4. The 1 over 4th I pulled outside. Okay, so integral of cosine is just sine. Okay, and then we back substitute. So 1/4 sine x to the 4th plus c. And that is this guy. function f is defined by the equation this guy. If g is f inverse and g of 4 is 2, what is g prime of 4? Okay, so this is a classic derivative of an inverse question, and as always, I never remember the formula, so I always quickly derive it. So we are given that f inverse is g, right? So let's call that y. So if I could, since they're inverses, okay, back up. So I wrote y is f inverse of x. So I could equivalently say x is f of y. Okay, that's how inverses work. Now, I differentiated both sides here. So derivative of x is just 1. Derivative of f of y is f prime of y dy dx. And let's solve for dy dx. dy dx is 1 over f prime of y, but y is f inverse. So it's f prime of f inverse of x on the bottom. Okay, and then remember, g is f inverse. So I could actually write this as f prime of g of x. Okay, so g prime of 4 would be 1 over f prime of g of 4 by my derivation. Okay, what is g of 4? They give it to us. So we want 1 over f prime of 2. What is f prime of 2? Well, we need to differentiate f. So it'll be 3x squared minus 2 is f prime. So f prime of 2 is 10. Okay, and then we plug in this here, so it'll be 1/10. Okay. F is this guy, f prime is 0. We need to use chain rule. So f prime is log of stuff, derivative of log of stuff is 1 over stuff times derivative of the stuff. Okay, so 1 over stuff is whatever's inside here, so I just copy that there. Derivative of the inside is derivative of e to minus 4x is negative 4e to negative 4x. Derivative of 5x is just 5. Derivative of 4 is just 0. Okay, so f prime of 0 would be, I plug in x as 0 everywhere. What is it? I plug in x as 0. So follow the math yourself. I get 1/5 times 1, which is 1/5. Okay. Now we have 2 more problems. I'm going a lot quicker in this second part, actually, unless these 2 problems are hard. F is a twice differentiable function with f prime greater than 0, f double prime less than 0 for all real numbers x. F of 2 is 5, f of 3 is 9. What is a possible value of f of 4? Okay, so I even tried sketching it to see if it would be helpful. It's actually not that helpful, but the key here is f prime is greater than 0. That means f is increasing. F double prime is less than 0, so that means f is concave down. Okay, so let's go with the first statement. I said first, f is increasing. So if it's 5 and then 9, f of 4 must be greater than 9. So we can eliminate these 2 already. All right, now we have to use the fact that f is concave down. What does that mean? Concave down looks something, if it's increasing and concave down, it looks something like this. So the rate of change is going to slow down. Okay? So that's what I wrote over here. So f of 4, well, that's when we said f is increasing, it has to be greater than this point. All right? Because it's a 2, 3, and then 4. Okay, so f of 3 is 9. So f of 4 has to be greater than 9. So that's why I eliminated those 2 one more time. Okay, now, if it's concave down, that means, well, what's the rate of change from 3 to 2? The difference was 4. Okay, so going from 3 to 4, it has to be 9 plus some value smaller than 4. Or the difference f of 4 minus f of 3 has to be less than 4 because the previous step was already 4. So since it's concave down, and I just said the rate of change is decreasing, so this has to be less than 4. So what's 9 plus 4? That's 13, so it cannot be these 2. Answer is C. That's how I would solve this one. Okay, and then last one. F prime and f double prime are all positive for any real number x, which the following graphs could be a graph of f. Okay, so it's very similar to here. We have to talk about increasing and decreasing and concave up, concave down. So first of all, f is always positive for any real x. So we can already what's the word I'm looking for? It's implied, that's not the phrase I'm looking for, but hopefully you know what I'm saying. That means that the function is above the x-axis. Okay, so since it's positive, so we can eliminate b right away. If f prime is positive, because it says that means f is increasing all the time. So where this one f decreases, right? Decrease, then increase. Cross that out. It's always increasing. Here it's always decreasing. Cross that out. Now we're left with A and D. It has to be concave up. This is a concave up all the time. Here it's concave up and then concave down. So it cannot be A. Choice D. Okay. And that's all for the no calculated portion. Please like this video if this has helped you in any way. And also please subscribe to the channel if you want to see more videos like this. And you'll also get notified for when I post the calculator required portion. I'm doing that next. And that'll probably be the next video. So subscribe to get notified for when that gets released. And I'll see you in that video. Bye.